This is the video for the January 2015 examination paper for the Applied Science and Maths exam. The way I'll do these videos is the first video will be an introduction, and then I'll do one video per question so that you can see sort of the thought processes. So whenever you get an exam paper, what I recommend you do is just spend a couple of minutes without even putting pen to paper. Look through the thing, build your confidence. So let's have a look at what type of questions we're going to be tackling across these next few videos. Right then, question 1. This looks like vectors to me. Okay, so there's some resolving going on here. Complete the vector diagram, calculate the resultant force. Nice. Next one, we've got a steel rod of length 0.8 and has a diameter. What will be the extension of the rod? Okay, so this is looking like stress strain. Extension, strain. So that's changing length over original length. Okay, not too bad. Perfect, this is what we want to see. It's a cantilever beam supporting two loads. We've been given a cross section, so I'm immediately thinking calculate I, second moment of area. Cantilever, calculate maximum bending stress. So that's going to be the 3-part equation. Not too bad. Okay, good start. Question 2. What have we got here? A bar has total length 1 meter. 3/4 of the length is steel, 1/4 from aluminium. What's the extension of the bar? Okay, so it's a little bit more of a complicated extension question. So they're going heavy on the stress analysis here. And then we've got 2B, a beam simply supported 5 meter span, tubular cross section. So that's going to be calculate I should think. Inner diameter. Okay, so it's going to be the pi d to the 4/64 one. Calculate required beam diameters when the load's applied mid-span. Okay, this is stuff we've done. It's worded in an interesting way, but as long as you go down the route of draw your diagrams, state relevant formulas, state the variables, it'll all start becoming clear. Hallelujah, we get a network analysis question. This is what we're talking about. So basically there's 10 free marks there. Good. We got some integration rather. That should be, if you practiced it, another 10 free marks. Good. Right, we've got a torque question, which isn't something we've covered in too much depth in the lectures, so it'll be worth practicing this in this video. 6 marks of S equals ut plus alpha t squared. Perfect, we'll have that. We've got some kind of fluids question. What do they want? It's a Bernoulli's question, but they've worked out the area for you. Okay, fine. We've got football pitch. This is weird. A football pitch measures 30 by 60. Calculate the length of this line. Goodness me, they've given us a year 9 trig question for 4 marks. We've also got a calculate the radius. Right, okay, we've got a quadratic equation question, and we've got a differentiation question for 8 marks. Now this is where your exam practice comes in. On first sight you will think, I haven't blooming done these, but you start writing down the things that matter, you'll soon find that it's all stuff you've covered. So I would say it's one of the harder papers I've seen. There's nothing to worry about. That and that, there's 40 marks that are in the bag. That should be no problem. 20 marks. Another 10 there, there's 30 marks. 40 marks. There's basically like 45 marks of stuff we have to do without even thinking really. The rest of it, we'll need to just take it step by step. So we'll start off with question 1. Good luck. And just remember that you can take your notes. So if you work through this exam paper with me and you're organised enough to print it out ready for the exam, it's an open book exam, and Amal has confirmed that we're actually allowed to use these notes in the exam. So what an absolute bonus that is. Let's get started. So this should be, the next video in the playlist will be question 1.